In learning objective B, we're going to solve right triangles for their angle measurements. So let's take a look at this one. It says here in triangle ABC, the leg opposite A has length 20, the leg adjacent to A has length 21, and the hypotenuse is 29. So let's first sketch this. This doesn't have to be drawn to scale, but if that's my right angle, again, I know that's the hypotenuse, so this is going to be 29. And they're saying here that the leg opposite of angle A is going to be 20. So why don't I call this angle A up here? And if you go opposite, straight across from A is going to be 20. Then we're going to call this angle B. And it says here the leg adjacent to A has length 21. Adjacent means you touch it. And then I'm assuming here is going to be our C. So I think we have a good picture of it. They want us to calculate the sine of A, cosine of A, and tangent of A. So let's just set those up using angle A. Remember the sine of A would be opposite over hypotenuse, so 20 over 29. Now the cosine would be adjacent, so that's adjacent, and this is the hypotenuse. So I'll write that here. The cosine of A is adjacent over hypotenuse. And then the last one is the tangent. Tangent is going to be opposite over adjacent, so the tan of A is going to be 20 over 21. So we have them set up and we found the sine of A, cosine of A, and tan of A. Now I want us to find the measurement of each angle. One thing you want to remember how to do is how do you solve for the angle when it's embedded in the word sine, cosine, or tangent. There's a button on your calculator, and what you're going to see is there's one that says sine, then the other is cosine, and the other is tangent. Right above each of those buttons, it should say sine -1, cosine -1, and tan -1. Whenever you need to solve for the variable when it's embedded in the word, like this is, the way to get the answer is to use the -1, or what's called the inverse button. So what you do here, for this one for sine, all you're going to do, the measurement of angle A is going to be equal to the sine -1 button of 20 over 29. For cosine, how do you get A out of the word of cosine? Well, the measurement of angle A is going to be the cosine -1 button of 21 out of 29. And lastly, how do you get the A out of the word tangent? You're going to do the same thing, but you're going to type the measurement of angle A is going to be hit the tan -1 button of 20 out of 21. And when you do that, what you're going to get is you're going to find that this equals 43.6 degrees. Well, when you type this for cosine, it's going to equal 43.6. And when you type this for tangent, it's going to equal the same thing. So you would never do this 3 times. You would just do it 1 time. So if we know that this angle is 43.6 degrees, can we find the last one? Sure. The last angle here is going to be angle B, and all we have to do is take 180 minus 90 minus the 43.6 degrees, and that's going to leave us with 46.4 degrees as the other angle. Let's try this example. Find the missing side and the 2 angles. Let's go ahead and actually find the angles first, and let's look at angle A. So to find angle A, since I only know one measurement is 90 degrees, I have to use SOHCAHTOA. So I'm going to look and see that notice that I have the opposite side and the hypotenuse. So opposite and hypotenuse is sine. So I'm going to say the sine of angle A is 8 over 9. Now I'm almost done. I want to get what the measure of angle A is. So the measure of angle A is just that inverse sine, or the sine -1 button, of 8 over 9. When you do that, you're going to get that it's 62.7 degrees. So I'm going to write that in at 62.7 degrees. Now angle B is going to be easy to find. All I need to do is take 180 degrees, subtract the 90 I already have, in the 62.7, and that's going to leave me with 27.3 degrees for angle B. Now the last step is to find side length x. I could use Pythagorean's theorem. I could do x squared plus 8 squared equals 9 squared and solve. Or I could do a ratio. And I'm going to do a ratio. I'm going to use this angle here of 62.7. And I'm going to use the fact that I don't know x, which is the adjacent side, but I know hypotenuse. So that would be the cosine. So I'm going to do the cosine of 62.7 is equal to x over 9. Algebraically to solve, just multiply both sides by 9. So x is going to be equal to 9 times the cosine of 62.7 degrees. When I do that, what I'm going to get is about 4.13 is the length. Now I'm going to think about if that seems logical. 4.13 is the length. I'm going to write in that this angle was 27.3. So one of the connections you hopefully remember from geometry is the smallest angle is always across from the smallest side. And our smallest angle is 27.3, and this is the smallest side. Again, you're going to see the largest angle is 90 degrees, and that is across from the largest side. This will always happen in every triangle.